Alright, in this video we're going to talk about the binary search algorithm. Now the important thing for a binary search is you have to start with all of your data set in order. Now this is in sequential order and now it is. This is in sequential order, we're not missing any spaces. That doesn't necessarily matter that there's no gaps, it just matters that it's in order. So this data set is perfectly fine as well, but for the sake of this demo, let's just use all the numbers from 2 to 10. So suppose I'm searching for a number, let's make it, how about 4? So I'm going to try to find the number 4. Now in a linear search algorithm, I would just start looking down the list until I find the thing I'm looking for. In a binary search algorithm, it works a little bit differently. So the first thing I'm going to do is take the size of the list. 1, 2, 3, 4, 5, 6, 7, 8, 9. Divide that number by 2, which gives me 4.5. But 4.5 really gets truncated to 4 in Java. So I'm going to go to that middle position, 0, 1, 2, 3, 4. All right. And this is kind of my pivot point. So what I'm going to do is compare the thing I'm looking for to the thing that's at this pivot point. And if the thing here is bigger than what I'm looking for, I can ignore this whole half of the data set. I don't need to look there anymore. If it's smaller than the thing I'm looking for, I can ignore all this whole half of the data set. And if it's the thing I'm actually looking for, I just return it. So I compare 4 to 6. I realize that 6 is bigger than 4. So this whole half of the data set is now eliminated. I don't have to worry about it anymore. What happens now is my last index gets moved to here. I take the size of the list again, 4, divide it by 2, so I get the number 2. And then I go to the second index. So 0, 1, well actually in this case it would be the third index, but 0, 1, 2, I check here and I compare it and I found it. So that was pretty quick. Now in a linear search, I would have found it on the third pass. This time I happened to find it on the second pass. But where binary search is really, really helpful is when you have very, very big sets of data, because what you get to do is cut away half of it on every single pass. So let's just do it again to show you what I mean. And this time we'll search for the 10, which is all the way at the very end. So in a linear search with an ordered set, I'd have to go all the way to the end of the list to find that number 10. But again, I'm going to start with the center, compare it to the 6, and say 6 is smaller than my number, so this whole half of the set goes away. Now I have 4, divide by 2, so 0, 1, 2. I compare to this index. Now I say that's still smaller. This whole half of the set goes away, and then I'm left with only 10. So I've only had to do 3 searches to find my the piece of data I was looking for, even though it was all the way at the end, and a linear search would have taken me, in this case, 9 looks. So that's a binary search algorithm. I hope that this demo helped make some sense.